hopefully you have watched the videos on how to solve inequalities with addition and subtraction and the video solving with multiplication and division. Well, today we're just going to put it all together. So we'll start with this one. And again, we want to start with the getting rid of the addition or subtraction first. So we're going to get rid of the positive 9 by subtracting 9 from both sides. It should look very, very familiar. And then I will have p divided by negative 8 is greater than 4. And at this point, we're going to multiply both sides by a negative 8. And when I do that, I want to remember something very special here. And we'll have p, and this one side will be negative 32. But as you remember, whenever I multiply or divide each side by a negative number, my sign must flip to its opposite. And so the answer is p is less than 32. And since we've already done a video on how to graph these, I'm not going to graph them in this video. Here we have another problem, and there's actually two different ways you can do this one. The one that you're the most familiar with is to distribute before you do anything else. So we'll take that 6a, and we'll distribute to both things inside. Negative 6a and then minus 12. And again, we're going to get rid of the whatever's adding and subtracting to a first. So we'll use the inverse operations here. That comes nothing. On this side is 18. It's greater than or equal to negative 6a. Now we'll get rid of the negative 6 by dividing. And on this side we have a negative 3. On this side we have the a. And then what happens with the inequality sign? Does it stay the same or does it flip? I hope you said it flipped because we did divide by a negative number. And so the answer to this one is negative 3 is less than or equal to a, or a is greater than or equal to negative 3. Here's a little bit more difficult problem, but it's not that bad. The only difference is you have the m on both sides, and that's what you need to take care of first. And so what we're going to do is we're going to get rid of this 3m over on the right-hand side by just doing its opposite. So that's a negative 3m. We're going to put a positive 3m. And I'm going to line it up with what I'm going to combine, because I can only combine like terms. And over here, I will have a 4, and a negative 2 plus positive 3 is a positive 1. So positive 1m, or I can just say plus m, is greater than 7. And I want you to just stop for a minute. I know that we took something that was multiplying times m, and we moved it over, but we really looked at it as a term that's either adding or subtracting. And because of that, we did not flip the sign. All right, next step. Got to get rid of the 4. The 4 is positive, so I'm going to use a negative 4 to get rid of that. And I have left m on this side and 3 on this side. Do I flip the sign? No. I did not multiply or divide either side by a negative number. And so I am done. Now we're going to start looking at a couple special type of problems. Here's a long one for you. And the very first thing I want you to do is just combine like terms wherever you can. And I think that's it right there. And I'll have a 3g minus 4 is less than or equal to a negative 3 plus 3g. And right now you've got to be looking at it going, okay, my g's are going to cancel out. And you're right. But this time, just because the two numbers are different does not mean it is no solution. I want to show you what's going to happen here. And so I'm going to go ahead and I'm going to get rid of my 3g's. All right, they're both positive, so I'm making them negative. And I have a negative 4 is less than or equal to negative 3. Is this true? Yes or no? Well, yeah. Negative 4 is less than negative 3. And so this is not no solution because it's true. The answer to this one is, ready? All real numbers. And I know it seems weird, and it's like, wait a minute, why is the other one infinitely many solutions and this is all real numbers? Sorry, it is. This is the way they do it for inequalities. Now I want to show you one that actually is a no solution. Okay, take a look at this one. And the first thing I need to do is distribute both. And so 4 times 1/2 and 4 times negative 2 will give me 2x minus 8 is greater than, and then 2 times both of these, I have 2x minus 6. And as you can see, the 2x is going to cancel each other out. So I will subtract 2x from both sides. And what I have left is negative 8 is greater than negative 6. Is that true? No, it is not true. And so this one would be no solution. Of course, I can't finish this video until I do a story problem with you. So here it is. A runner's times in minutes in the 4 races he has completed are 25.5, 24.3, 24.8, and 23.5 minutes. The runner plans to run at least one more race and wants to have an average time less than 24 minutes. Write and solve an inequality to show how the runner can achieve his goal. First, let's define the variable. So let x equal number of minutes for last race, the one that he's going to do right now. All right. And as you remember, an average, you just add them all together and divide by how many you have. And so our inequality is going to start like this, 25.5 plus 24.3 plus 24.8 plus 23.5 plus our unknown, x. All over what? 5. All right, and he wants his average time to be less than 24 minutes. So that's pretty easy, less than 24. Getting rid of that 5 would be a good first start. However, then I'd have to rewrite that entire line again. So what I'm going to do is I'm going to add those all together first. And I'm going to get a 98.1 plus x all over 5 is less than 24. And now I'm going to get rid of the 5 by multiplying both sides by 5. And I'll have a 98.1 plus x is less than 120. And it looks like I'm going to have to move this up a little bit so we can see it. There we go. And finally, I'm going to get rid of the 98.1 from both sides. And I get x is less than 21.9 minutes. Wow. So in other words, if he wants to have this average time of less than 24 minutes, he's going to have to run the best race he's run all season. All right, you're ready. Watch out for those solutions of all real numbers and no solution. Also watch out for when you need to flip a sign and when you don't. Have fun.